Your laptop is dying, 15%. You reach for the charger, you plug it in, and without a single thought, you walk away. But here's what nobody asks. What just happened inside that little black brick? You pulled power from a wall running on alternating current. Voltage surging back and forth, 60 times per second, and somehow, your laptop didn't explode. How? That black box does something most people never think about. It doesn't just transfer power, it transforms it, and the engineering inside is far more elegant than anyone gives it credit for. For most of the 20th century, power adapters were heavy, clunky, hot. They used large iron cores to step voltage down, simple, brute force, inefficient. Then in the 1970s, engineers began experimenting with a different approach. What if you didn't fight the electricity? What if you just changed how fast it moves? That idea became the switched mode power supply, and it changed everything. Here's what actually happens the moment you plug in. The AC power enters first, it gets rectified, converted into rough, choppy DC. Then something surprising happens. That DC current is switched on and off, tens of thousands of times per second. Think of it like a fan blade, spinning slowly. You feel gusts spinning fast enough it feels like steady wind. At high frequency, the power becomes smooth, controllable, quiet. A small transformer steps the voltage down, another rectifier smooths it out. Feedback circuits monitor the output in real time, adjusting constantly, like a thermostat that never sleeps. What comes out the other end? Clean, stable power, exactly what your laptop needs. Now consider the scale of this. Billions of these bricks are plugged in right now, across the world. Even when your laptop isn't connected, just the charger sitting in the wall, it's drawing power, quietly, continuously. We call it vampire load. In the United States alone, idle chargers and adapters consume enough electricity each year to power millions of homes. A small black brick, a global energy problem. But here's what almost no one knows. That charger isn't passive. Modern laptop chargers communicate through a tiny data line buried inside the cable. Your charger and laptop negotiate with each other every few seconds. How much power do you need? How much can I safely deliver? It's a conversation, digital, silent, invisible, and if something goes wrong, if the charger is counterfeit, damaged, or poorly made, that conversation breaks down. Sometimes the result is a dead battery. Sometimes it's a fire. That block of black plastic isn't just a charger, it's a real-time power conversion system, a negotiator, a safety valve. Every time you plug in, a small piece of engineering history quietly does its job, protecting your machine, managing global energy flows, speaking a language you never hear. The most overlooked object in your bag might also be one of the most sophisticated. If you found that interesting, there's a lot more hiding in the ordinary objects around you. Stick around.